Right, hello Internet. This is the long-awaited video regarding the novice diagnosing of broken graphics cards. I've been working on this project for a while, as I've mentioned in previous videos, and finally it is happening. So as you can notice, the video quality is much better. I've acquired this broken graphics card from the internet. This is a XFX RX570 4GB version card. It was sold on the internet as not functioning. As I'm not a electrical engineer, electronics repair shop or anything, I had to study and research how is it done properly, what are the components are on the board and everything. So after all of this and some troubleshooting on some other cards, I'm fairly confident that I'm finally able to take a few small steps on how it is actually done. Basically, I'm gonna tell you about the basic layout of a graphics card. Obviously, not all graphics cards are the same. They will differ from one to another, but the components are pretty much the same, and it's the positioning that changes, along with some other parts that sometimes are at the back of the PCB as well. Basically, the most common in all graphics cards is the GPU core. As you can see, that will never change. It's always in the middle of the PCB, and it's quite pronounced, and you can see it. If you can see that it has this shiny texture and everything. So if you get a graphics card that has the core broken and it does not appear to have a mirror finish like this, and you can see it's brittled and cracked, that means the GPU core, the die, is broken and the card is basically dead, unless you have exactly same GPU core and you can replace it through a specialized process. If you're a technician, that card is dead and you can use all the other parts, if they're still alive, to repair other graphics cards. But for this example, this one seems fine. You can see the mirror finish. It's excellent. So the GPU core in the physical state is perfectly good. Then you have the power delivery system. So you have the 8-pin, which is here, which provides 12 volts to the graphics card. And then you have the PCI lanes here. You can see there's a notch here, which distinguishes the rest of the power delivery with the data lines. So on the right, these are all the data lines, that all the data from your computer going back and forth to the GPU. And on the small notch, you have 12 volt and 3.3 volt coming from the PCIe express slot into the card. You can see all the capacitors, resistors, smaller capacitors, SMDs. There's really tiny ones here. This is SMD is called basically surface mount device, so voltage regulators, really small capacitors. The power delivery after the voltage enters through the PCI slot and the 8-pin goes through the MOSFETs. The MOSFETs are basically the power delivery from the GPU core, who regulate downgrade from 12 volts. Obviously 12 volts can fry the GPU core, and so you will see a bunch of these chips converting 12 volts and regulating 3.3 and everything else through these chokes or power inductors and the capacitors into the GPU core. These black dots here are the memory chips. They're not on the back. Some cards have them on the back as well, not this one. You can see memory. So this part regulates the GPU core. This part here on this specific card regulates the memory, and you have smaller as other SMD devices that do have separate functions. So as I told you, this choke here, along with the capacitors and the regulators, regulate the memory. We spoke about the power delivery to the GPU core. So this small part draws and regulates power to these memory chips. These MOSFET give power to the GPU core, as we mentioned. This part here, let me bring it a bit closer. So this part here regulates the display signal, display voltage and output from and into the core. And on the back you can see there's more SMDs, of course. This is a voltage regulator that regulates voltage from and to the GPU core. As you can see, it's you can notice the proximity to the 12 and 3.3 volt lane, and you can see that there's something missing here. I'll try to bring it closer. So I already diagnosed, I'm pretty sure I diagnosed this GPU correctly. So when I received this card, there was no video, there was nothing. So when you have a card and you want to diagnose it, you need to know the resistances of these components, and you need to know the numbers of how to measure them. As I said, I'm not an electronic engineer or anything, but you can find these numbers on videos from experts and actual engineers on the internet. So if you have a broken graphics card, the next thing you're gonna need is a multimeter, a digital multimeter. For example, I've purchased this from eBay. It's 20 quid or something. It's pretty simple, and it will allow us to diagnose everything. So let's say we have a damaged component through the memory, on the memory rail. If we know the resistances, we can diagnose if this is working fine, and when put on the PC, if the voltage output is the correct one and it can drive all the memory chips. If not, we know that the problem is somewhere here. There are multiple layers of difficulty and problem solving. I'm just scraping the surface. So if it was me and I felt the resistances were off somewhere in the display rail or a memory rail, I would just know that the problem is somewhere here, and I would ask actual experts about this. If not, and the layer is deeper and you have, let's say, really small SMDs broken or burned or anything, there are actual schematics from these graphics cards on the internet, somewhere hidden. I don't know, some people have them, other people don't. I don't know where they acquire them. Some of them are free, some of them you need to pay to view. But on this specific card, just to rewind back, nothing was working, there was no voltage or anything, so all the resistances were fine, but this voltage regulator, as I mentioned at the start, was not putting the correct voltage out for the card to initialize and bring the voltage to the GPU core for the GPU core to work properly. So I've actually replaced it already. So this is a new voltage chip from spare parts from AliExpress/China, but the problem is still consistent. So I'm still new with also soldering. So when I soldered this piece of this voltage regulator back, one of the 3 feet was not touching properly. I didn't have a hot air station, which I now have, and when I actually soldered this correct, I've noticed that all the resistances before replacing the chip were normal. After replacing it, they were abnormal. So One of these, the external little foot here was not touching the board, created a back current and fried this this other voltage regulator. So this is the 5 on this specific card. This is the 5-volt regulator. This is the 1.8 voltage regulator. As you can still notice the proximity during all these PCI lanes, and you can, on close-up, you can see the traces and everything. For each card to function properly, there's a so-called power sequence. So when the card is properly functioning and receiving all voltages and everything's working as intended, the power goes through a number of stages, enables specific parts on the graphics card, and if these parts, they then enable the next part for it to work. If something's missing from the power sequence, then you won't have a good graphics card, and that means obviously something's broken. After I replaced the 5-volt regulator, I was waiting for the part for the other voltage regulator, which it's a 5 to 5 year old graphics card. I couldn't find the parts anywhere, so I had to wait for a couple of weeks to arrive from China, and they have arrived. And since I have everything ready, I'm presenting you with this video and hopefully a fix. Just to let you see what everything should be as it should be, I'm gonna walk you through how to properly diagnose it if everything's working correctly. So we open our multimeter and we put it there. We have the 2 probes, red, black. You need to touch the ground, which is usually it's this part, the I/O shield, anywhere. One of the small keyholes for the screws here. These are also connected to ground, so we're measuring resistance from ground to each component from each component specifically. And I have already written the resistances for this specific card from other videos from YouTube, so we can go ahead and check if these numbers are true. For starters, whenever we're having a graphics card that's broken and we don't know what's going on with it, we need to check if there is a short on 12-volt and 3-volt. And in order to do that, we take our multimeter, we switch it to beep mode to see if there's a short circuit. So whenever the 2 probes touch, you can hear the beep. So one probe on the ground plane, you can see if I touch here or here, it beeps, and we're looking for shorts anywhere on the power plane of the card. So 12 volts on this specific part of the PCB here, on these surfaces, gold-mounted surfaces, is the 3rd pin from the left. So 1, 2, 3. There's no beep, so there's no short on 12 volts. So that means whenever we're plugging on the card, it's not going to burn out or it's not going to explode, but it will definitely cause damage. Now we need to check for 3.3 volts. So we need to go from this notch 4 pins on the left. So 1, 2, 3, 4, 5. 5 is ground, and you can hear it beeps, and 4 is 3.3, and there's no beep. So that means 3.3 and 12 volts are fine. We need to check now the other part of the power plane that's coming from over there. Again, 1 probe on the ground and the other one on one of these voltage inductors, and there's no beep. And we can check the other one. So these they're like output filters, if I'm not mistaken, and if something's wrong with the power plane, they will show. If there's a short circuit, they will it will tell us. So again, no beep. If we touch somewhere else, randomly you can still hear the beep. So the voltage, the power plane is fine. So now we switch back to regular resistance mode on our multimeter, and we can check these numbers out. So display rail 14 ohms. So one probe on the ground, and I know per fact that this part here is the voltage rail. So I'm touching with the other probe, and oh no, that's the wrong side, sorry. And I touch on the other side, and we have 28 ohms. So this is perfectly fine. This is just a reference. If it should be fine, but as long as it's not shorted. Remember, we have a component missing on the other side, so this number is fine. So we can check the 5.5 volt rail. So we go on the back of the card, and we go on the component that I've already replaced, and we go on this pin here. So we're supposed to be finding 550 ohms, and we have 275 and rising. But remember, we have this part missing, so this is actually half, so it's actually okay. Next one is 1.8 volts. So 1.8 volt is this regulator that it's missing. Obviously, right, small interruption there. So as I was saying, we have the component missing, so we cannot actually test the exact resistance. So it's supposed to be 1.8 kilo ohms. So if we touch to ground and touch on these three capacitors, which I know they're fed from the 1.8 volt, we have 2.475 kilo ohms. Which is a lot, which is like 900 ohms more, but again, we are missing that component. Then we can check the memory phase, and I know per fact that it's this inductor here on the back, and if we touch it and we get, hold on, I don't know if the camera can pick it up, and we get 530 plus. So normal resistance is 350 ohms, so it's more, but again, we have a component missing. Hopefully when I replace this, all the rest of the resistances will match up. And last but not least, VDDCI, which is supposed to feed the core and the power sequence. So it's this component here. So we touch, and we have 30 ohms. Baseline is 18, so it's good. So now that we know what's what, and we have the resistances, and we know what's missing, and we know that everything is more or less okay, we can go, if somebody's more able to go deeper into diagnosing, obviously, and one of these resistances are off, you know pretty much already if something needs to be replaced or not. If all the resistances are fine, we now head to the next part, which is putting the card on a test bench and checking out the voltages while the card is being powered on. I need to warn everybody, because putting a card without the heatsink on a test bench and while the GPU core is heating up can be dangerous, because obviously there's no transfer heat protocol to the cooler. So if the card is partially functioning and the core is getting full voltage, and you're not really careful with measuring your voltages, you can fry the chip, because there's nowhere for the for the chip to transfer its heat, and it will burn out. So when a card is on the test bench and you need to measure voltages, you need to be really quick, or you can put a small heat sink on, connect to a PCI riser, so all the heat is being transferred to there and you don't burn the chip. In this case, this specific card, when it's plugged in, there's minimal voltage going into the core, so the core should be receiving 5 volts. It's receiving 3.3. I can touch on activation when I'm putting my test bench on. I can put my finger there. I can see that it's getting warm, but there's no image. There's nothing going on. The computer won't go into Windows at all. So I can measure all the voltages with no heatsink on, and I know that the chip is fine because I can touch it. GPU cores can reach 100 plus, and they can burn out themselves. Some of them don't have heat resistance, good heat resistances. They don't have auto throttling or something, so they will burn out if you leave them long enough, and they can reach 100 plus degrees Celsius if left untended. This specific one I could feel is getting warm, so maybe it's like 30 degrees. I can feel the difference with my hand. When you're going deeper and deeper into diagnosing, if there's a short in any of these components, you can use also an infrared camera, which is a lot of it costs a lot of money, and it can pinpoint exactly which component is shorted or damaged and needs to be replaced. So when I was measuring the voltages, and I noticed 3.2 volts are there, I was touching with my hand. Obviously, I don't have 300 pounds to buy an infrared camera. So I touched the 1.8 volt and it was scalding hot. So I knew there was a short, and the resistances were way off after I replaced the 5 volt chip. So I knew that that component needed to be changed. That's a quick, brief mention of how to diagnose, basic diagnose cards. I'm still working on other ones, parallel, waiting for other parts, and trying to diagnose the rest of them. But this is a basic guide what to do. Again, I need to clarify, I'm not an electrical engineer. I don't know where is going what. I can identify some components watching other videos, and I know some parts what their job is, but my soldering skills are really bad. Hot air station skills as well, so I don't know if I'm going to be able to properly diagnose this card and properly fix it, but I'll try my best. I'll close the video off now. When you'll see the next image, hopefully I have this component here replaced, and we'll remeasure all the resistances again. Hopefully they will go more in par with whatever we have here on our list, and the card, after powering up, I'll show you my test bench, and hopefully it will power up properly. Yeah, see you soon. Right, hello again. I'm recording this a couple of days later after the initial video. We left off where I'm supposed to be replacing the 1.8 volt regulator here, which I did. Unfortunately, well, as I mentioned earlier, I'm not an electrical engineer or anything. Was the replacement. I don't know if the camera can pick it up. This was the replacement 1.8 volt voltage regulator. It has a ground pin underneath, which I failed to solder, and I'm thinking it allowed high current to go into the 5 volt regulator here, which I had already replaced, and it burned it out because the 5 volt regulator was showing 10 volt output, and then it was not working. So it stopped working, so I'm guessing it shorted out. So I had to desolder the 1.8 volt regulator, solder everything back again along with that base ground plane, and that was working. That is working fine now. And then I had to replace the burned, shorted 5 volt regulator with a new one, and now the voltage output on the 5 volt regulator is 5 volts. 1.8 volt is here. Unfortunately, you don't see the card running because it's not running. So my hopes were to replace these both chips, and the card will be functional, since in the power sequence 1.8 volt is here, 5 volt is here, and after 5 volt is here, VDDCI should turn on, and that should give power to the power stages and to the GPU core, and the card should run. And it's not, so VDDCI is missing, vCore is missing, the voltage for the power for the memory is still here, so that's fine. The display output is here as well, it's present, it's 0.9 volts if I'm not mistaken, but unfortunately the VDDCI and the vCore supposed to be powering the GPU is not present, so the card is not running. So for some reason I need to find out why it's not running. The last culprit that so I'm going to look deeper into it. My first hunch is that this PWM signal is as a signal. This PWM IC chip driver is not running, and I think, I'm not sure, this might be the culprit of why the card is still dead. I can still feel when the card is connected, I can still feel that the GPU core is getting warm and everything, but unfortunately there's no picture, nothing's happening. The card acts as it's dead. So my hunch is that this driver chip here, driver chip is dead. I'm not sure, as I said, I'm gonna look into it, but for now I don't have any other ideas what to do with the card. If somebody has any suggestions, please let me know. Just gonna give you a quick rundown of the resistances, so you can compare before to after. Let's start. There's no shorts, obviously. I'm not going to check 12 volts and 3.3 here on the PCI Express. I know this card is not short, so we're going to measure resistances. 1.8 volts, and it shows 3001 ohms. Basically the resistances are all high. VDDCI is 32 ohms. The memory should be fine. What else? The resistance on the 5 volt is 157. As you can see, it should be in the area of 500 ohms, and it's not. Here we'll measure it again, and it's not. And 1.8 volts is 2.5 kilo ohms, and it should be 1.8 kilo ohms. The memory is 550 and rising, so that should be fine, but the resistances across the card are higher. Let me show you the core as well. So the core is fine, so I'm pretty sure the core is not dead, because that's the 0.0 0.8 ohms is what a normal GPU core should give out. So yeah, that's it for now. I'll keep you updated, but again, if somebody has any suggestions that's wiser than me, more experienced, because I'm still tapping in the dark here, please let me know. And otherwise, I'll see you in the next one. Thank you.